A cavity preparation or tooth preparation is defined as the mechanical alteration of a defective, injured, or diseased tooth to best receive a restorative material that will re-establish a healthy state for the tooth, including aesthetic corrections where indicated along with normal form and function. Difficult to mug this. Yes, but if you are able to get the gist of this, and even if you put this definition in your own words, so it is a mechanical alteration or mechanically altering a defected or an injured or a diseased tooth. If you can alter it so as to receive a restoration or a restorative material that will put back the tooth to health. Now, when you put back the tooth to health, what should it be doing? Its job of the tooth is for biting, that is mastication, for looks, that is aesthetic. So it is for aesthetics, for form and function. So when you are studying, you study in such a way that you understand this meaning. Don't mug it up, right? So it will be easier for you. So it is preparation that is done with a machine on the tooth, right, to clear defected part, injured part, diseased part, and then to place a restorative material over there that will put that tooth back into health, the normal health, such that it can have proper form, it can have proper aesthetics, and it can have proper function. Okay? Have you understood this? Now we go on to the next. Now what is the objectives of cavity preparation? The objectives would be you remove all the defects with the protection of the pulp. So the pulp protection has to be done and all the defects should be out. Then you have to extend the restoration in a conservative manner, not in a haphazard manner, right? Now, we say there is an extension for prevention, but you have to be more conservative in your approach, and under the force of mastication, the tooth or the restoration, when the patient starts biting, the tooth or restoration should not fracture, should not break, should not get displaced. So, and last, aesthetically and functional placement of the restorative material. So, you should remember these 4 or 5 objectives that are there. Now, having understood these objectives, basically let me again repeat for you, removing all the defects. The defect can be a crack, it can be a discoloration, it can be dental case. Then you protect the pulp. Then you try and, if required, extend the restoration in a conservative manner. So you get a better form, contour, and you can take care of the various steps which I'm going to talk about. Now, and then when you bite or the force of mastication comes on the tooth, the filling and the tooth, that is the restoration and the tooth, both should not fracture and should not be displaced. Also allow for good aesthetic and functional placement of the restorative material. Now, once you define a cavity preparation, the next step, any examiner will ask you, please define steps of cavity preparation. And GB back steps of cavity preparation are the basics that we all should know. Right? So they will ask you, please give me the steps of cavity preparation. You should immediately say the steps are outline form, resistance form, retention form, convenience form, toilet of the cavity, finishing of the enamel walls and margins. The moment you give this smart answer, the next thing they will ask you is define any of these things and talk about it in detail, right? So you must understand and you must learn these properly right in the beginning. So the GV Black has given us these steps or the principles for cavity preparation, which is the outline form, resistance form, retention form, convenience form, toilet of the cavity, and finishing the enamel walls and margins. The final steps after that is done is to remove any remaining enamel pit or fissure, infected dentine or old restorative material, do pulp protection, if required any secondary resistance and retention form, finishing the external walls of the cavity, and final procedure is cleaning, inspecting, and finally sealing of the restoration. Okay? I'll repeat it once more. Outline form, resistance form, retention form, convenience form, toilet of the cavity, finishing of the enamel walls and margins. These are the initial points or the initial steps. The final steps are whatever remaining dental caries, defects that are there, infected dentine that is there, or restorative material that is there, that has to be removed. Then you have to do pulp protection. Then if required, if you feel a lot of the tooth structure is lost, you might have to do some secondary resistance form and retention form feature. Finish the external walls of the tooth preparation, and final procedure is cleaning, inspecting and sealing. Now, when you are going into these steps are the same whether you are going to do an amalgam, you are going to do a glass ionomer, you are going to do a composite, you are going to do a inlay preparation, you are going to do a laminate veneer preparation, you are going to do an onlay preparation. But depending on the material that you are working on, there can be a few differences here and there. So very often, if you start answering well, then if the examiner wants to drop a little bit of a bouncer, they will say, oh, what material are you using? So you have to say, sir, I am talking about amalgam. For composite, it is slightly different. For glass ionomer, it is slightly different, right? So this is the way you will be examined. This is called the deep learning process. So now, if you're having a full question, you define, write down the properties, write down the different steps. Now we'll take each step. And you can have a short note also on each of these steps, right? So the outline form means you decide the final position of the cavity preparation margins except for finishing the enamel walls and margins. The initial or preparing depth, the initial depth should be 0.2 to 0.8 millimeters below the dentino enamel junction. Remember, all cavity preparations have to be below the DE junction at about 0.25 to 0.5 millimeters below in sound dentine, never in enamel. Okay. Now, there are some situations like if you're doing a composite, maybe you can get away by doing an enamel preparation because there they're going to use some other steps, right? So you have to be aware of this. This is how, also get into the habit of making some artistic diagrams. You know, very often if there is not enough time or if you're not very comfortable writing or it takes long for you to write, then the best thing for you to do is to be in touch with some amount of drawing so you can explain things better, right? So here you can see the outline form includes all the pits and fissures. It includes the mesial and the distal margins, okay? And this is a 5-cut type, right? Now, all weakened enamel and friable enamel should be removed. That is, no unsupporting enamel should be left behind. All the faults should be included, whether it is decay, whether it is crack, whether it is stains or any such problems. The margins should be placed in such a position that you can afford good finishing of the margins of restoration. That is very, very important. Now, extend the preparation margin until sound tooth structure is obtained and no unsupported or weakened enamel remains. Avoid terminating the margins on extreme eminences such as cusp heights or ridge crests. If the extension from a primary groove includes 1/2 or more of the cusp incline, consideration should be given to capping the cusp. Okay? So these are points that you must mention. You know, here is a diagram that shows you exactly where is the cusp tip and all. So if you can understand, you can go ahead and depict it with diagrams also. The preparation margin should include all the fissures that cannot be eliminated by enameloplasty. So all these fissures should be included. Now, here automatically one question comes, enameloplasty. What is enameloplasty? So instead of making a full cavity here in this fissure, suppose you take a round burr and run it over here, immediately this groove can become like a concavity and you eliminate that fissure, that deep fissure where caries can occur and you have a concavity. So food will not get stuck over there. You are in enamel and also the chances of decay happening will be reduced, right? So this is what is enameloplasty. The initial pulp depth should be about 0.2 millimeters into dentine, but if it's a gold foil restoration, it should be 0.5 millimeters, right? So here, whenever you reply, you never give one figure. You give like you can give 0.2 to 0.5, 0.2 to 0.7. So always you don't confirm with one figure, always you give a range. That's very, very important. Now when the occlusal enamel has worn thin, where total cavity is 1.5 millimeter. Connecting them too close to the falls or cavity preparation. So you can if there are two, if you are doing a upper first molar, very often you do a different mesial cavity and you do a different distal cavity. You don't cross the oblique ridge. So in case if there is only 0.5 millimeter difference between both the cavities, you might as well, you're better off connecting both of them. And extend the outline frame to provide convenience form. So it should be not too tiny that your instruments don't go in. What is the point of having a cavity preparation if your a plastic instrument and your condensers don't go in? So it should be of a size which is not too big, that is, you're not weakening the tooth by too much loss of tooth structure. At the same time, it should be such that your instruments can go in when you want to do your base application or when you want to condense your amalgam. Now step 2 is the resistance form. Now again you can get a question, please define resistance form and how do you achieve it. Okay, short note. So you have to then talk about definition. Primary resistance form is defined as that shape and placement of the preparation walls that best enables both the restoration and the tooth to withstand fracture without fracture the masticatory forces. So what does it say is the shape that you give to the cavity such that neither the filling, neither the tooth can fracture when you are masticating or when it is being subjected to masticatory force. Got it? So I'll repeat again, primary resistance form is defined as that shape and placement of the preparation wall that best enables both the restoration and the tooth to withstand without fracture masticatory forces. Right? Now, how do you do this? There should be adequate thickness of restorative material. There should be a good box shape and there should be a flat floor. So you should know how much thickness of the restorative material. So for amalgam, how much you require. For composite, how much you require. For glass ionomer, how much you require. Then the shape of the cavity should be box shaped. It should be flat pulpal floor. It should not be a rough floor. Right? These are very, very important things. So a flat floor, when you see over here, will prevent the restoration moving. There will be no movement of the restoration. But if you have a round pulpal floor, little bit of the restoration can rock. If the restoration rocks, then it will become loose. So it is always better to have very clean, straight, flat floor. No rounded pulpal floor. This may, especially if it is a non-bonded restoration like amalgam. Maybe if you are using composite or you are using glass ionomer where we are using bonding mechanisms, then you can think about having a, you're okay with not having very, very flat line angles. Okay. So these points you must be able to understand, you must be able to print out, you must be able to speak. The floor should be flat, okay, and relatively parallel to the cusp tip. Okay, see that it's parallel to the cusp tips relatively, because that is how, this is not right. This is what you should have. Right? Because here you won't know if the forces come, and if you are undermining this cusp can become weak. So it has to be relatively flat floor, relatively parallel to the cusp tip. Right? So these points all you must include when you are writing. Your Cavosurface margin. Now the preparation should be such that if you are doing an amalgam, you have a 90 degrees butt joint. The Cavosurface is a 90 degrees butt joint. If you are doing an inlay or a onlay, the Cavosurface is a 25 or 20 to 30 degrees lap sliding joint. Okay, if you are doing composite, you have to have a finish line on a finishing margin on the enamel, right? So, and then you have to bevel it, right? So there are different types of bevel: slide bevel, long bevel, short bevel. Okay, so these different bevels are there. So depending on the different material that you're going to use or the restorative material that you're going to use, the design may differ a little bit. So basically, you should have no unsupported enamel, slightly rounded internal line angles. If you feel lot of tooth structure is removed and the cusps have become weak, think of capping those cusps. preserve the cusp and marginal ridge as much as possible. And if required, if you're doing a composite or a glass enamel, then you can look at the bonding of the restorative material. So that will also give you good resistance. That is, when you have no unsupported enamel, you have slightly rounded internal line angles, if you have capped the weak cusp, if you have preserved the cusp and the marginal ridge, which are nice and strong, and if you are going to use a restorative material like composite, then the bonding of that composite material, the bonding technique that you use, these all contribute to the resistance form. This all contribute to factors that will prevent the filling or the restoration or the tooth from fracturing when it is subjected to masticatory forces. I hope you have got the fundamentals clear.